Welcome to the Explainer. What if I told you that the single most important shield protecting all life on Earth is completely invisible? Well, today we're going to explore that exact shield, our atmosphere. And we'll also look at what happens when this protective blanket starts to get a little frayed. So let's start with that big question. What is this all-important shield? I'll give you a hint. It's not something out of a superhero movie. The real answer is all around us, every single second of every day. You guessed it, it's the atmosphere. It's this huge, gaseous envelope that makes all life as we know it possible. But, just calling it air doesn't even begin to do justice to what it actually does for us. I mean, think of it like Earth's ultimate multi-tool. It's a really thin layer when you think about it, but it performs all these absolutely critical jobs that separate our living, breathing world from the cold, harsh emptiness of space. Its importance is just staggering. The atmosphere is our planet's sunblock, absorbing deadly UV rays. It's our thermostat, keeping temperatures from swinging wildly. It provides the carbon dioxide for plants, the oxygen for us, and it even acts like a global delivery service, moving water all across the planet. It's nothing less than Earth's life support system. But here's the thing, this blanket isn't just one solid piece. It's actually structured in these really distinct layers, and each one has its own kind of bizarre and vital job. To really get it, we need to take a little journey, straight up. Okay, so we start here, in the troposphere. This is our home layer. It goes up about 10, maybe 16 kilometers. It's where we live, it's where planes fly, and it's where all of our planet's weather happens. From a tiny little breeze to a massive hurricane, it's all happening right here, thanks to the constant mixing and churning of the air. So let's go a little higher. Above the troposphere, we find the stratosphere. It's a lot calmer up here, very little mixing going on. Its most famous resident, of course, is the ozone layer. That is the critical band of gas that acts as our main shield against the sun's most damaging ultraviolet radiation. Now, here's where things get really interesting. In the troposphere, as you go up, it gets colder, right? Think about climbing a mountain. But in the stratosphere, it actually gets warmer the higher you go. Why? Because that ozone is busy absorbing all that UV radiation. This temperature flip creates a kind of lid on the troposphere, which is what traps all our weather down below it. Pretty cool, huh? Okay, keep going up, and we hit the mesosphere. And here, without that ozone layer to warm things up, the temperature absolutely takes a nosedive. We're talking about a plunge down to a frigid minus 92 degrees Celsius. And then finally, we reach the thermosphere. This is the atmosphere's outer frontier. The air up here is incredibly thin, but it's the first line of defense, and it absorbs the most intense energy coming from the sun. And this creates a temperature profile that just seems to defy all logic. That's right. The temperatures up here can soar to 1,200 degrees Celsius. Now, you wouldn't feel hot in the way we think of it because the molecules are just so far apart. But it gives you an idea of just how much high-energy radiation our atmosphere is shielding us from every single day. So, we have this beautifully complex, layered system that's protecting us. But it's also a system that we are having a major impact on. So, let's introduce the conflict into our story. Air pollution. What does that term actually mean? Well, the key thing to get about pollution is this. It's not just about the presence of some substance. It's all about its concentration. A tiny bit of something might be totally fine. But when it builds up to a level where it can actually cause harm to us or to our environment, that's when it becomes pollution. And the range of pollutants is incredibly diverse. We're talking about gases like carbon monoxide or something called particulate matter, which is really just a fancy way of saying tiny, invisible particles of smoke and dust. It can even include radioactive materials. So where does all this stuff come from? Well, a really big chunk of it comes from us. Let's take a look at the anthropogenic or human-caused sources of air pollution. I mean, our modern world is basically powered by activities that release these substances. Generating electricity, driving our cars, industrial manufacturing, construction, even just our garbage decomposing in landfills, all of it contributes to the mix of pollutants in our atmosphere. When you look at a list that long, it's pretty easy to think that pollution is an exclusively human problem. But that brings up a really fascinating question. Are we the only ones responsible? And the answer to that is a resounding no. Nature itself is a massive source of many of the exact same things we call pollutants. The atmosphere has always had to process these materials long before we ever showed up on the scene. Think about it. Volcanoes spew ash, huge storms whip up dust, and even a peaceful forest is constantly emitting millions of tons of something called volatile organic compounds. That's the stuff that creates that pine scent you love. You add in natural fires, pollen, and you start to see that our atmosphere is this incredibly dynamic system, constantly balancing what comes from natural sources and from human sources. And really, understanding that balance, that the atmosphere is this finite, shared resource that's affected by both natural processes and our own actions, it brings us to the fundamental question. Knowing everything it does for us and knowing what it's up against, we have to ask ourselves, how can we best act as protectors for this vital, irreplaceable blanket?